Hello portable radio operators, and this is HB9EHA. In this video I'll show you a light and compact vertical HF antenna system built mostly from commercial components that I tested on several summits in France and Switzerland. You'll find more information about all the parts that I used in the video description. For a while now, I've wanted an antenna that can be easily deployed on space-restricted summits where you don't have enough space for wire antennas like my end-fed half-wave. Since such summits typically can be found in the higher mountains, the whole antenna system should be also as light as possible and easy to set up as well. Further, since I don't want to carry a tuner, the antenna should be resonant on several bands. The antenna radiator is a widely used base-loaded, about 2.5 meter tall commercial antenna that is sold under different brand names such as GABIL, Sharman, Kommunica, or more recently the MA830 from the German distributor WIMO that I purchased. I asked WIMO where this antenna originates from, and it seems that it's made in Taiwan, which is probably the reason why you can't find it in the typical Chinese online stores. Technically speaking, it's a shortened lambda quarter monopole antenna with non-resonant radials. The antenna is usable from the 40 meter to the 6 meter band. The antenna package also contains an 80 meter band coil, but using it on this band doesn't make much sense for a number of reasons, and so I omitted this band in my tests. This antenna is connected and fed at the bottom by a UHF or a PL-259 plug. I found a mechanically sound mounting solution from the eBay seller BD7 Maple that I discovered on the HOA Ham YouTube channel. This mounting solution consists of a ground spike with a UHF socket to attach the antenna. To connect the coaxial feeder cable to the mount, it originally used a UHF socket as well. But if I can't choose, I prefer a BNC connector instead, without an adapter that can get lost. Further, the original ground spike was a bit short. So I asked the manufacturer if he could fit a BNC socket instead and a longer ground spike, which he did. Great, so I could focus on the ground radials. After some reading and modeling, I decided to go for 8 2.6 meter long radials. It's always a trade-off regarding weight, simple deployment and efficiency. For easy setup, I added a small loop to each radial to easily attach it to the wire winder. When the soil is too hard for the ground spike, I either use some stones or the backpack to hold the antenna more or less vertical. The whole antenna system, including 3 meters of RG174 feed line and all the other bits and pieces, weighs in total 740 grams. This is more than an AX1 or similar screwdriver antenna that is attached directly to the transceiver. But my vertical antenna is definitely more versatile and efficient. I tested this antenna extensively on several summits, and when I had enough space, I compared it with my 20 meter long end-fed half-wave. To quickly change the frequency, I marked the bands on the coil ruler. Many times this was good enough and I didn't have to fine-tune with the transceiver's SWR graph feature. After my tests on different summits, these are my conclusions. It's a viable solution for space-restricted setups, for example on a tight summit peak. The whole antenna system weighs only 740 grams and needs little space in the backpack. The setup is simple and only takes less than 5 minutes. The SWR on all tested summits and bands from the 40 meter to the 6 meter band is always below 2, mostly below 1.5. Therefore, no tuner is needed. The antenna shows a good performance on the higher bands, especially for DX, because of its low radiation angle. By higher bands, I mean the 20-meter band and up. It's a compromise antenna on the 40-meter band, due to its low efficiency on this band. It's not usable for NVIS, which stands for Near Vertical Incident Skywave. This is no surprise, since the radiation pattern of a vertical antenna has a primary gain towards the horizon and a hole in the vertical direction. When changing the band, the antenna has to be adjusted. Compared to an end-fed half-wave, this is a disadvantage, but you mostly get a better preselection. And finally, the included 80-meter band coil is not really useful and can be left at home. I hope I could give you some ideas for this kind of antenna. Please comment below about your own experiences. If you enjoyed this video, please like it or subscribe to my channel. Thanks for watching. 73. Bye bye.